Hello and welcome. Today we're going to be looking at some questions from the M1 Mechanics Edexcel International A levels. We're going to be looking at tough questions where the idea is not usual, or it's a new idea and it's a tough question. Okay, so I haven't found lots of videos combining tough M1 questions, so I will be doing a series where I solve these questions and explain as I go through. Okay, so let's start with the first question. Let's read a block. It says a block of mass 9 kilograms is released from rest from a point P, which is h meters above a horizontal soft ground. So if we have a horizontal ground, there is a point P here, and on this point we have a block of mass, which later in the question it says that it's modeled as a particle, so I will just model it as a particle and call this P. Okay, so this is block A, this is point P. Okay, they're both at the same place. So it says the block falls and strikes another block B of mass 1.5 kilogram, which is on the ground vertically below P. So there is another block of mass, which is B, okay, is directly below the first block. So it gave me that the speed of A immediately before it strikes B is 7 meters per second. So this block is left to fall, and its velocity just before it strikes B is V, let's call it VA, equals 7 meters per second. And the first question tells me to find the value of H. So this is H over here. Let's call this H. So this is very obviously a kinematics question, because I have V's, I have a distance, I have U. I know that the acceleration of free fall is 9.81. So let's solve it as a kinematics question with the famous Saviot equations. So what I like to do is I like to write each letter, and in front of each letter the equation that doesn't contain this letter. So S standing for displacement, the equation that doesn't contain displacement is V equals U plus AT. Similarly for A, it's V equals U, it's S equals V plus U over 2 times time. The equation that doesn't contain V, or final velocity, is ut plus half at squared. The equation that doesn't contain U is S equals Vt minus half at squared. And finally, the equation that doesn't contain time is V squared equals U squared plus 2as. And I start to look at what is the givens in the question. So relating to particle A, well, I know that it was released from rest, so I know that UA equals 0 meters per second. I know that V equals 7 meters per second. Okay, and I'm taking downward as positive, so V here is downward, so it's positive. And I know that my A is 9.81. My A is one second. Let me try to reconnect this. Yeah, so my A is 9.81 meter per second squared, and my S is H, okay, or I don't know what is my S. So I come here and I look at which letter didn't I mention. I mentioned U, V, A, S. I didn't mention the letter T, so I will use the equation in front of the letter T, which is V squared equal U squared plus 2as to find my unknown. So V squared, which is going to be 7 squared, equals U squared, which is 0 squared, plus 2 times acceleration is 9.81, and S is basically H, and I would expect S to become a positive value as I'm taking down as positive, and S is below A, or H is below A. So solving, I will have 49, and then I will divide by 2.981, which is equal to H, which is going to give me 9.81, so 2.5 meters. So this is my answer for part A. So let's now read part B and try to understand. In part B, it says immediately after the impact of the blocks. So now I know that the block A hit or struck block B. So from this, I get the hint that there must be some sort of momentum happening, or momentum change happening, or conservation of momentum. So it says that they move downwards with the same speed. So the blocks join as a single entity and they move with the same speed. Let's call it speed v. And both come to rest after sinking a vertical distance of 12 centimeters into the ground. So let's imagine that this is mud. Now both blocks are here. They are moving with the same speed v, and they moved for 12 centimeters before they stop completely. So from here, we know that we started with some sort of velocity v, and we ended with a velocity that is 0. So I know that I have acceleration here, or negative acceleration, or I have deceleration. Okay, so this is not a constant speed question. I have acceleration in this second part of the question. So assuming that the resistance offered by the ground has a constant magnitude of r newtons. So the force from the ground on the block causing this resistance is called r newtons. The question asked me to find the value of r. So here, let me remodel the blocks. So this is block B, this is block A. They are both falling down. Okay, I will model them both as the same thing. Okay, and combine their masses. So M will equal M1 plus, or MA plus MB, which is equal 9. I believe 9 was the mass. Yes, 9 plus 1.5 kilograms, which is basically 10.5 kilograms. So I have here, let's try to think about the forces that are acting on this body, the combined body. So I know that there is the weight, which is going to be equal mg, or 10.5 g, and I know that there is a force from the ground called R, which is the resistive force, which is what I want. And I know that the block is going down. However, the acceleration is acting upwards. Why? Because the speed is decreasing. I started with some speed v, and I ended on the below the ground 12 centimeters with a speed of 0. So if my speed is decreasing, then my acceleration is opposing my speed. So if my speed or direction of speed is down, then my acceleration should be upwards. Okay, so let's do the forces equation. And by the way, here it's no longer an equilibrium equation. Why it's not equilibrium? Because equilibrium happens when we are at rest or we are moving with constant speed. As long as I have an acceleration, then this is no longer equilibrium, so I will not equate these forces to each other. However, I will do something like this. I will take the direction of acceleration as positive, so upward as positive, and I will add my forces together. So I know R is acting upward, so it's going to be plus R, and then I know that the 10.5 G is acting downward, so it's a minus 10.5 G. This should equals mg, which is 10.5, sorry, ma, which is 10.5 times the acceleration, which is this acceleration in this part right here. So in order to find r, it's very simple. I need to find acceleration. When I have my acceleration, I can solve for my r. So let's see what happened here. So after the blocks struck each other, the blocks, because of momentum, this whole new combined mass thing is now moving with some speed v, mentioned here in the question, and it will move downward at 12 centimeters. So in order to find acceleration, I will need to use my kinematics equation to find it. However, in order to use the kinematics equation, I will need to know my initial speed v. And how do I know that? As I said, there is an impact that happened. So let me try using conservation of momentum here. So I know that conservation of momentum says that MAUA plus MBUB, so basically momentum before the collision equals to the momentum after. And since they both joined, I will act as they are a single object with the combined mass MA plus MB times the speed v. So MA was 9 kilograms, UA was 7. That was the speed just before the collision. If we remember, B was here, A was here, and was given that V before the collision was 7 meters per second, plus MB, which is 1.5, times UB. B was at rest, so B is 0 here, equals 9 plus 1.5 is 10.5 times my V. This is my speed after the collision, so the speed of the combined masses. So to find that, it's basically 9 times 7. This is 0, and then divide 10.5. So 9 times 7 over 10.5. This is going to give me a speed of 6 meters per second. So what happened here is after the collision, both blocks now are moving with a speed of 6 meters per second for a distance of 12 centimeters, and my v is 0 meters per second. So now I can start to use my kinematics for these equations, for this scenario right here. So let's see, what do I have? I have my initial velocity was 6, which was the speed where they started moving with, so 6 meters per second. I have my v, which is 0 meters per second. I have my s, which is 12 centimeters, so 0.12 meters. And as I said, I'm taking downwards as positive, so u is 6 meters per second downwards, so it's positive. V is 0, so no positive, no negative, and I know that my displacement is below my starting point, so it's also going to be downwards, so it's a positive value. And my A, I don't know. So again, which letter didn't I mention? It's basically the letter T, so I will come and use the equation in front of T, which is v squared equals u squared plus 2as. So v squared is 0 squared plus equals u squared, which is 6 squared, plus 2 times a times 0.12. I will find that my a is negative 6 squared, so negative 36 over 2 times 0.12, which is going to give me an a of 2 times 0.12, so an a of negative 150 meters per second squared. And I notice here that my a is negative, and I'm taking down as positive, so if a is negative, it means that a is acting in the upward direction, which is what I expect. So now, since a is 150, or the magnitude of a is 150, we can use it in this forces equation now. So I have an r equals 10.5 times 150, and then plus, when I move this 10.5 g to the other side, so basically becomes plus 10.5 g. This is going to give me an r value of 150 plus 10.5 times 9.81, so it will give me an r value of 1678 newtons, or 1680 newtons. This is my answer for the first question.